let's tackle this Lab 2. It's a little later than I want it to be. At the same time, it'd be good if you got started on it already, because I do have a conflict. Essentially, I go back and forth on whether I should guide you through this whole thing or do part of it, or you guys attempt it first. I think when you learn on your own, it's better, but not if you get stuck. So, and then I know some people are not going to come forward and say, "Hey, I'm stuck," and then it's better than nothing if I guide you through the whole thing and I can tell you about things as I'm doing it. So I don't know. We'll see how this goes today. I might not do the whole thing. It depends on the momentum and how I feel, but and I guess feedback too. Your Access Lab 1 needs to be graded soon too. You guys, there's 2 sections of you, so there's like, depending on how many people turn it in, anywhere from 40 to 60 or so, somewhere in there. I have to double check the numbers, but it's a large group, and I have other classes to keep up with too. And I made your video, your lecture video. So if I do that, I'm not grading. So I apologize. It's only a little bit over a week since you turned it in, so it's not that late, but I don't like for it to go much longer than a week before you get feedback on an assignment. That's another reason to like help guide you through this one too, because you haven't got feedback on a similar assignment that you've already had. So we'll see how it goes. But I'm just downloading this Access file, Lab 2 files. There's a couple things in here because there's a starter kind of Access database, and then there's also the I think there's an Excel sheet with data in it, if I remember correctly. I've done this one before. I know this is the hardware software setup. If you watch the most recent lectures, you'll see some correspondence as to what we've already gone over. Because keep in mind, Access is an example of a relational database. The engine, I forget what's Jet engine. It's not Jet, is it? There's an engine, the actual database management system at the core. I forget what it's called. I don't know if they've changed it over the years or not, but it's a relational database at its heart. It's got a lot of bells and whistles on top that makes it. It's meant to be like something it's meant to be a solution, in my opinion, anyway, for people who are not necessarily database administrators, to be able to manage a small database. So it's meant to be user friendly-ish, though it's kind of, if you've never done databases, it might kind of seem awkward or counterintuitive at first. But anyway, let's get started. So download this access files zip. Really, this probably should be extracted to, let's see, make the hide the magic behind the curtain here. Let's see. If you have a 1303 folder, that would probably be a good place for it. So I want to select that folder to extract in. Then I'm going to pause so you don't have to wait for me to get everything situated. All right, so once you've finished extracting, you should have this. This is the sort of starter database, and no, it's not. This is not starter database, is it? This is the database you already have for this class. Sorry, I'm not thinking it. This is the starter database, the hardware tracker. It's meant to, let me tell you the purpose of it first. It's meant to kind of track software and hardware installations in, say, a lab. Originally, this was a sort of, it's called Pella Shifty or something. It was supposed to mirror like how the labs are set up at school and stuff. That's just as an example of how things work. So here's the starter access database, and we'll actually go through the instructions first. We won't just go ahead and get started yet. We'll read those first. But I just wanted to give you a look at what you should have if you download that script. So you should have this access database. See, it's an access database extension. Then you should have a couple of Excel sheets. And this is another thing about Excel. I don't know if I went into this in much detail, but another way Excel, I meant for you to compare Excel spreadsheets to databases to see how they're similar and different. But it's also Excel, I should say, not necessarily Excel per se, but comma separated values. They'll often come in the form of Excel spreadsheets, but anything where you have a list of data, especially comma separated values, it's just like, in this case, you've got What this is actually a bridge table. I don't know if you remember that from the discussion, but see how it's hardware ID and software ID. This is saying that piece of hardware number 1 has software 53 installed on it, and it also has software 54, and et cetera, et cetera. This is going to be a bridge table, but the data can be delivered to databases often in the form of spreadsheets, also something called XML, which we'll go over at some point, I'm sure, and other ways, just random different ways. But those are a couple of more like formal, structured ways to deliver data to a database. So that's called config. Basically, config, that set of data is telling what's installed on what. And then this is a table of hardware. So, and I want to say this is not necessarily a perfect table as is, but it is a table that you can have and access. We'll critique it as we go and work with it, and et cetera. But there are issues I have with the way this data is structured. And I don't remember what they were on top of that. I know one thing. I do remember one thing. See how it says RAM? Then you have 8 gigabytes, 256 megabytes. See how you have two things here? This is awkward for data. You should just have a figure, in this case a number, because you're talking about an amount of RAM. So what you would decide when you're at design time is that you would specify that RAM in this database, main memory is what it really means. Main memory is often called RAM somewhat inaccurately. But that's fine. We can call it RAM. That's not the big issue. The big issue is that you've got 8 gigabytes mixed with 256 megabytes. What you should do is settle on one measure and then just put the units. So let's say everything's in gigabytes. And I don't want to do the conversion here because I want to say, I might be wrong about this. So, test me. But 8, if it's all gigabytes, then you could say 88.25 for 256, because that's a gigabyte is 1,024 megabytes, right? Well, really, it should be 1,000 bytes. I'm sorry, 1,000 megabytes, or a billion. It's 1,000 megabytes. 1,000 million would be a billion. Yeah, I double check me on those. I'm not good at mental math, but it should be powers of 10, technically speaking. But you notice how memory is often done in powers of 2, because 256, I don't know if you know this, but that's a power of 2. It's 2 to the, well, let's see, it's not 2 to the 10th, so it's not 9th, 2 to the 8th, I think, is 256. That sounds right, because 7-bit ASCII is 128, so 2 to the 8th would be 256. Double that, you get 512, double that, and you get 2 to the 10th, which is 1024. So you notice that powers of 2 are often used to express memory. And I thought my eyes are blurry. Are these all? Are some of these MIB? Or are they all MB? Yeah, I need my contact that gives me good vision wore out. And I'm getting, it was a trial, so I'm getting boxes sent from. I won't advertise for him, but you probably know who is sending the boxes of content. So I'm having trouble reading now. Let's see if I can do this. Obviously, yeah, it's just megabytes. So megabytes technically is a power of 10. Mega is a million. So 10 to the 6 bytes. You're saying you have 256 times a million, basically, bytes. I'm way off tangent here. I'll off on a tangent. The long and short of it is I think this column should have one measurement, say gigabytes, or megabytes is probably better. And then you would express everything in terms of that one measure without the GB and the MB and all. You would leave that out. And that would be same for the hard drive space, both of these. That would be an easier way to store that data. It's kind of awkward this way because you have to do some kind of conversion at some point. And that means you have to read the whole thing and think, oh, this is gigabytes, this is megabytes, so that means this or that. If you were like saying, what's the total amount of hard drive space we have in the whole lab, for instance? Well, you got a mixture of gigabytes, terabytes. That's the mixture you have here, only those two. And here, how's the total amount of main memory? I don't know why you want to ask that question, but you could. What's the total amount of main memory we have in this lab? Well, you would have to do a mixture of conversions. And it's just a lot better if you if you make it to where you don't have to do that at design time, you would do one conversion at the end. You would retrieve the amount of data, and then you would, if you wanted to express it in gigabytes, you have a front end that would do the math for you. It would take that figure you get back and convert it to whatever you want. Anything. So that's the data. That's the hard. This is about all the hardware, I guess, computers and the hard drives and stuff in them and everything. So that's the data. So the data is being packaged in these two Excel files, but then you have the database that you're going to enter into. So let's look at the actual. This is all, by the way, somebody had trouble finding it. Everything should be always in the checklist. So if you go to course helpful, whatever, not that one. It's weekly activities in this class. I need to standardize it across all my classes so I don't get lost. So you see, I've got these are going to be revealed eventually, but we're on week 4 right now. And if you look in week 4, you got week 4 checklist. Always go to that first, in my opinion, because everything you need to do is in here. So I made a video lecture if you missed it. There's the slides. And then you've got complete access lab 2, which is due on the 15th. That's the actual document. This is where you put it when you're done. So if you click on Access Lab 2, it's not the actual document actually. It's a little module that has the document and the thing that I downloaded. So you download both of these things. These are the instructions, and it's also what you turn in, because you have some answers you have to put into the document and then submit that document. And then these are the Excel spreadsheets in the database and everything. So this is what I was just showing you. So let's see what the instructions tell us to do. All right, so here's the document. Put your name on it, because I think, if I'm not mistaken, you turn this in instead of the database this week. But you will need to complete the database or add to it in order to be able to answer the questions. So these are the things I already talked about how it tells you how to import data from an Excel workbook to Access table. There's a part where you add some images as data, so that's a thing you can do in databases. One possible value of a database field for a record, trying to be what's the precise about it, but fields can have binary values. I mean, it could be a picture or some other object that's just data. Data, of course, it's data. It's a database, but binary data. So pictures is one thing that you could have as a value. There's no reason why, as long as you specify that it's a certain kind of thing that you have there, say maybe JPEGs or GIFs or whatever, that's the value it could be, as well as like having names or numbers or whatever. Creating simple queries, so we'll talk about queries for the first time. Adding items to drop-down list, that's more of an access front-end interface kind of thing than it is a database topic. But, that's fine. And then using multiple criteria by joining conditions with that. So this is going to show you how to do some simple joins. If you notice, we have 2 tables here. We have the config and the hardware. I want to say there's a software table somewhere too. But regardless, we do have more than one table, and we're going to show how joins work. So I talked about this in the lecture video. So when I talked about, what did I talk about? Sorry, that didn't go anywhere. When I last checked, these videos work. Actually, this is the only one it didn't, so I marked it out. So when I go over this lab and show you how to do things, it's also true that you could just go to these videos and watch them. I will not argue with the fact that maybe some of these videos are clearer than the instructions that I give. The only thing I can be sure about is that you'll get the context of this particular class. So like things I talked about in the lecture video, I might relate to what you're doing here. So you'll get that from me. And maybe I'll mention things they don't mention in the video. But as far as like following step-by-step instructions, you've listened to my videos probably already, so you know that I'm not that straightforward. So your mileage may vary on which videos you prefer. Ideally, you watch them all, right? But if you're like, I'm tired of like waiting for him to get to the next step, I'm just gonna watch that was great. More power to you. Yeah, autodidacticism. That's I encourage that. All right, so the answers and the output for this lab should be placed in a single Word document rather than being printed as multiple documents. So please do that. So download this instruction document, the thing that we're reading right now, and insert your question and responses and screen captures directly into it. Please type your name at the top of the document. There's where your name should go. Now I'll probably know because I know which Dropbox I'm looking at, but you know, it's nice if you put it up there. And then you just edit this Word document as you go. You'll like click and paste or type or whatever the answer is. So for part A, download, we already showed that. Download the zip folder that I showed you before. It says your H drive. Again, this is when you were on campus. I just left this in because I'm like, well, USB drive is plain. Or you can just do your C drive. Like I showed you, I did the CT 1303 folder. Whenever it says H or USB, you can convert that in your mind. I can maybe go back and change all these too. But just wherever you want to save it, actually, is what it comes down to. Wherever you want to do work on your computer. So set up a Lab 2 subfolder inside. If you actually just extract it, when you extract the files, it looks like it creates a Lab 2 subfolder anyway. So you probably don't need, you can skip that step if you want. One of the files included is a relational database. So there is that's the database file I was talking about. It's an Access database. Open it and immediately choose File, Save As with a new copy. So this is where I messed up on when I think when I did the Excel thing. So let's do this correctly. So actually, I wouldn't have Access running already if I were doing this. What I would do is go to my 1303. Wherever I'm doing this work for the Lab 2, right, I'm going to go directly do that on a different screen. So I would go here. Now just double click this, and I'll open up Access for you with the proper database to start. Yeah, that's what I thought. Some of the, you do want to enable content. It probably tells us to do that here in a second, but actually let's follow the directions exactly. They say the immediately thing to do is to go to File, Save As. And how do we save it? We save it as we append our name to, so it should look like that. So I did your name last time. So save database as, here we go, save as. And then you want to go double check in here. I go to my Lab 2. I would just go to my Lab 2 folder again. So you want to go where it has this, and I think it's underscore your name here. How's your name how should it look? Your name underscore your name, pending your name. This time it doesn't say how your name should look. I think it does in the original directory. But here's how I would like for you to do it. Just put at least underscore and your first initial and your last name. Like that. So I'm doing C. Nicholson. If you want to use your middle initial, that's fine too. I have the urge to put CJ Nicholson there. But whatever, however you do. Just have your name somewhere in here. The main thing is you save it as a separate file so you can always go back to the original one without having to re-download it. So once you do that, you'll notice at the top it says which file you're working in. You want to make sure it's the right one, and save the other one that you downloaded so that you don't you can go back to it again and only edit that one, the new one, with your name on it. So this is the wordy stuff. I think we already, a relational database composed of one or more tables, which are composed of one or more records. So again, a table is an entity. A record is an instance of an entity. So for each row in the table, that will indicate a particular, say, piece of hardware or a particular employee or whatever. And each record has a bunch of fields. So that's the whole tuple thing. A record is a tuple. It's a so many tuple. So all the fields together compose a record, which again is an instance of an entity. It's a relation. A record. Well, a relation is a table, but and an instance of a relation is a record in your table. And it says all this here. So that was me saying the same thing that it says in the reading. But so in your object browser, which is the object browser is the Does it ever say, hold on. All right, this is bothering me the whole time. It doesn't ever say to enable content that I see anywhere. You do want to enable the content at some point. What enable content is about is the fact that there's some programmatic things in these these Office files like Access and Excel and even Word that can do things that could be exploited to do things on your computer. So that's you only want to enable content on trusted sources. I want to say you can probably trust the file that we provide you on Brightspace. Ultimately, it's up to you, but you'll have to do it somehow or another in order to turn in the assignment right. So go ahead and enable content if you have it. This is the object browser over here. So what we have right now that we can see are 4 tables. So let's look at them real quick. If you double click, it'll show you, I forget what this is called. This is the design view, I think. There's different views you can have of these tables, but data sheet view, I think is what this was called. So what you can see right now, see how it's called TBL config? If you recollect, the Excel file that we have in that zip that we downloaded was called, I think it was called TBL config, or it was something config, had a bunch of data in it. Notice that this is empty. It hasn't got the data yet. We're going to end up importing that data, and we'll show how to do that here presently. If I remember correctly, TBL employee has all the employees in it already. And then hardware, we'll have to import the hardware, and then the software is already here. So let's take a look at the employee real quick, the employee table. What you'll notice is that you have this first field. This should be the primary key. I have to remember how that's indicated in Excel. I'll show you here in a second after pausing probably. But you'll notice you've got 1 field, 2 fields, 3 fields, and then you can add more. Access makes adding fields easy. So I just paused because somebody walked in the room. I'm self-conscious. I can't, like, if somebody walks in the room, I can't continue. So forgot what I wrote. I think I was counting off not tuples, but fields. So we've got, looks like an employee ID. I think this is not, what's the field name? Hold on, I think there's a better way to look at this. If you right click and go to design view, it's a little bit easier to look at. Yeah, so these are the names of the fields. The way I think about this view, so again, I right click and go to design view. It's right here for each of these tables. The way I think about this is the metadata. This is the data definition language of a sort, or a view of it anyway. It's telling you the structure of the table, not the actual data in the table. The way I think about looking at this is it's as if you rotate the this view right here, rotate it 90 degrees clockwise, and then do a mirror image. And that should kind of give you a lineup, if I'm right in my rotation in my head. It's close to it anyway, of what the actual table looks like when you fill it out. So what I mean is, like, you'll have EID on the left. So if you rotate this, right, you'll have F name, L name, EID, and then you do a mirror image, rotate horizontal, flip, and then you'll have EID, then L name, and then F name. Which is what you have if you double click on it and look at it in this data sheet view. Yeah, L name, then F name, right? What the design view tells you is stuff like the data type, and like this is all just for the sake of you, the designer of the database table, or whoever's reading what you created. These are just comments. So it's saying this is the primary key. And I think you can see it here. See, it has a little key on it. That's indicating that it's the primary key. It's been selected as the primary key. Access should ensure that you're not able to put a value in this column, EID, that's not unique. The data type short text, so it's not numerical or anything. It's just a bunch of characters. I forget how big short text is. We can maybe look here in a second, but and these are just comments. So this is not part of the structure. This is just commenting on the structure. This is the structure here. We have a column or field name, EID, L name, and F name, and these are the data types. And then it also indicates that it's the primary key. If you need to set it as the primary key, you can always right click and set something as the primary key. We already got one here, so that's not a valid option, but we already got it. So if you click on it, you also see more information down here about specifics about the data type and the domain and all that. Remember, a domain's the range of values that it can be. So part of the domain here is that it's so required means should mean it can't be null in this case. I'm pretty sure. Well, this is the by definition, a primary key can't be null. No part of it can be null. But if you look at this required no, you're saying you can leave that blank if you wanted to. But then again, you're saying you can't be zero length. So I would have to look at it. Field size 50, so you can have 50 characters. So that can vary. In this case, it's 20 characters for the first name. So you can get information about, this is way off from what we're supposed to be looking at in our instructions, but I just kind of wanted to take a look at all these things. So again, if you double click on it, it shows you the data sheet view. The data sheet will show you the column names, and it will show you the actual data that you have already stored in it. So we can see that employee 001 is Agnes Murphy, for instance. And then for the software, there should be an SID. That's what the name of this column is. It's the primary key. And then you can see that there's a publisher field, a title field, a license field. And now you want to define for the people using your database what this means. I think this means how many licenses you have for that product. So how many can you install? How many different machines? You notice I forget what this is called. It's the same principle of consistency means across the Windows world and even other applicants, even other companies, you have this kind of thing where you can spread out the columns. See, if you double click on it, it should make it the perfect size, right, to be able to read it. Anyway, so you got the publisher, and then you have the title of the software, and then probably the number of licenses you're allowed. If you want to, you can look at the design view of that. You can see that it specifies the primary key. This is what really specifies it. This is just helping somebody read that it is. Say, hey, this is the primary key. These are all short text. Notice this is a number. That means you can do math with it. So you can ask questions like, what's the software program? What's the software that we have the most licenses for? Or the fewest, or less than 5, or whatever. You can ask all kinds of questions. So if you add up all the licenses, how many licenses do we have overall? So lots of different questions you can ask. Remember, always in the back of your mind, keep in mind one of the benefits, one of the strengths of a relational database is that you provide a very clean, clear structure of what the data is and what the possible values are, the domain, and what data types and all that are for your data. And then you can ask novel questions about it, questions you didn't even think about when you were creating the database. And as long as you do it the right way, there are so many questions that you didn't think of ahead of time that you can ask. And obviously when you're designing it, you do want to have the questions, the typical kind of questions in mind that you might want to ask, right? But a lot of the work in a relational database, a lot of the logical structure of it takes care of that for you almost automatically, as long as you design it properly. And there's a bit more to learn about how to design it properly, but we're talking basically the basic things that we're talking about now are just how tables are constructed, and a little bit how the data domains are specified and the relations between tables, the relationships. Not really. Keep in mind, a relation is not the same thing as a relationship in the context of a relational database. So let's get back to our instructions. And what number are we on? We're on part A, I think. So we did this part, extracted, we opened it up, named it. Object browser shows that they're empty. We're going to import that data. So each record and table is a logical order. Yeah, okay, we know this. It's also known as an abstraction of an individual object, person, place, or thing. Also, it's an individual object, but it's the whole class of them is a relation or entity or a table. So you have a software table, a config table, a hardware table, an employee table. Each row is an individual employee. So let's open up the software table, view the data. We did this. So I did all this stuff already. I felt like that's what the proper thing to do was. So we've examined some of these tables. I'll let you answer this question. This is how I'm going to approach this. I think I'm going to make it to where I don't tell you the answers to these. And that makes it really handy. So I can guide you through it, but you need to think a little bit about what's going on at every part. So number 5, click the plus sign in the first column to expand the values underneath. What do you suppose HID listed there is supposed to represent? So let's look. about what they're talking about. And honestly, what is this? The software table we're looking at, I think. I think that's the one we're looking at. I've got two screens, but you don't. So, I mean, you might, but you don't in the video. So I have to keep flipping back and forth because of the fact that this is a one-screen video. I can probably make a two-screen. I have to see how to do that. But anyway, so we are looking at the software table. So the plus sign, they're talking about this thing right here. So this is a way of, well, I'm not going to tell you what the answer, I want you to look at, but just this is the thing they're talking about clicking on. So again, this is an answer for you to think about what that might represent. The HID right there. Okay, choose the relationships item from the database tools tab. So let's see what that is. All right, so database tools, tab, relationships. Okay, so what we've got here is a mini schema. You can also think of it as sort of a, it's not technically speaking an ERD or an entity relationship diagram, but it's functionally equivalent to one in a way. I mean, it could serve as one if you wanted to. It's sort of this is after the database has already been implemented. So it's not a planning document. Technically speaking, entity relationship diagram, in my mind, the purpose of it is a planning document. I guess it could also be just the documentation of what the eventual implementation is, but it should really not be the implementation. It should be the logical design. So even if you've implemented the database and you would say, okay, here's an ERD of the database I implemented. Here's the logical design of it. It's sort of like tomato in a way, but not really. There's a subtle difference, but anyway, let's look at it. So if you remember some of my lectures, I was talking about ERDs. The way this corresponds to an ERD is you have these one-to-many relationships. And if you remember, I said you can't implement in a relational database, not that I know of, you can't directly represent many-to-many relationships. Everything's a one-to-many relationship. So you'll notice that an employee, you have one employee who does something with more than one pieces of hardware. So he might install on, I'm not sure, I forget what the role is. In an ERD, this would be labeled with a verb, so you would know what this relationship is. But we know that one employee can do something to many pieces of hardware, and one piece of hardware, each piece of hardware has something done to it by one and only one employee. That's because it says one here and an infinity symbol here. Likewise here, and I know what this one is, we have a relationship. Originally what we had in the ERD possibly was, think of it as infinity to infinity. So a piece of hardware could have several different pieces of software installed on it. So one PC has Windows, Access, Excel, we'll stick with Office stuff, Microsoft, right? Windows itself, Outlook, whatever. That's one machine. Outlook could be installed on every single computer or only 5 of them, or who knows. So that's a many-to-many relationship. You can't implement that directly in a relational database like Access, at least. I've never seen it done. So if it's something you can do, network databases can do this, but not relational ones. So in order to make that relationship manifest, because you can do many-to-many relationships indirectly by having two, you break down the many-to-many relationship. Think of this as crow's foot on both sides by creating a table in between. And it breaks that relationship down into two one-to-manys. So the ones are on each side. It used to be many here, but now it's just one here and one here. And then the minis get flipped around and put on the new thing. In class, when I'm doing this, it'd be good if I had a video right now. I'll show many-to-many relationship by crossing my arms with 3 fingers stuck out like bird claws. And I'll say you'll have a many-to-many relationship, in this case hardware and software, between those two entities. And you can't do that directly, but what you have to do is convert those two many-to-many relationships by, you convert it to one many-to-many relationship into two one-to-manys. And the way I show it is I spread my arms apart to where I have the I don't know if you can visualize this. It kind of looks like gang signs or something. But I take, I've got the 3 fingers pointing to the outsides of my body, the sides, and then I pull them apart, stick my elbows out, widen my elbows, and then I'll have like my 3 fingers pointing to the middle of my chest for both hands, right? So you can imagine that config table is where my heart is, and the 3. So it helps me to explain it, and I think maybe it might help to remember if you imagine that motion. So when you have many-to-many relationship between 2 entities, 2 tables, to put it in the database, you need to convert it to 2 one-to-manys, and that's just imagine the fingers, the arms spreading apart. And I hope that helps. Maybe I should make a little video snippet. I have a hard time imagining people describing visual scenes through sound, so I sympathize with you if you're having the same problem right now. Okay, so this is and what is this? I did explain what it was. This is one piece of software could be installed on many pieces of hardware. So what this bridge table does is, you notice this is the primary key. This is the primary key. What's the primary key of this table? Let's look and see. And this is stuff that's probably talked about in the document, but if I miss anything, we'll come back to it. So go to the design view. Oh wait, can't do that here. You have to do it. I guess you have to close this first. This is the kind of stuff I hate. I'm not going to save the changes. That's fine. We'll come back to it if we need to. So I'm going to right click on this and go to design view. Dang it. What was it? Open user table open. Do you want to open tables read only? Yes, fine. That's whatever. It might not be set yet. That might be a tool we need to do. Notice that there's no primary keys here. What we eventually need to have happen is we take these 2 columns, combine them together into something called a composite primary key. So the value of both are needed to uniquely identify each row. So we'll come back to that and see how it works after we finish looking at the rest of this document. Okay, so choose the relationships. Here are listed all the types: one-to-one, one-to-many, many-to-many, otherwise known as connectivity. I'll say there's another otherwise known as, and if I could, I would go edit the document for everybody. There's another word for this besides connectivity when you're talking about all the relationship types, called cardinality. Cardinality is a specification of how many instances of each entity are involved on each side. That's the cardinality. It should be in your textbook. So aka connectivity, aka cardinality. Hold on. What you'll find is there are a lot of different terms that mean the same thing or similar things in database, and you'll find variations on. Don't freak out about it too much. Use the ones that I use in class and the stuff you also see in the reading and then the labs. Just make sure you're familiar with that style of it. But this is a crow's foot example. This is from Caleb Curry, whoever he is, but he's showing cardinality here. So there's a one cardinality and a many cardinality. So it's the number of things that can be involved on each side. Then you have modality, he calls it. I call it participation. I think the book calls it that. Participation tells whether or not something's required or optional. So he shows that here. So this is nullable, not nullable. He's got a little bit different terminology. So again, don't freak out about it too much. Of course, I pick up an example that kind of that sort of disagrees with me. If I stop and think about it, nullable kind of makes sense actually, because you can have 0 or more. So the 0 would be the nullable. Anyway, would be the null. But anyway, if you notice, optional relationships, what he calls this one, and then probably mandatory. Yeah, so mandatory looks like this. Mandatory many, mandatory one. That's those two examples. This is optional many, optional one. That's what that looks like. Except that it's going in that direction in this case. And you can see here what this is covered in my lecture video, but I just kind of want to review it. I like, again, I want to repeat these things, especially in context. So this is saying that a customer can have 0 or more orders. He might not have ever ordered. He's a customer because hey, you want to be our customer? Yeah, we'll add you to the database, but he hasn't bought anything yet. That would be, if that's the business rule that you're describing, you could also have the business rule that they're not a customer unless they bought one thing at least. Then you would make this not a 0, you make it a line, which means mandatory. Depends on what you want to represent. And in this one, an order will have something will be ordered by 0 or more customers. So you can maybe never have the order, or if it is ordered, it will be just one. It won't be ordered by many. I don't know how you have an order without having a customer, but that's something in their business rule. Connectivity, so a relationship between two tables. Yeah, okay, so it's just saying that one-to-one, one-to-many. Cardinality, minimum, maximum number. To me, these kind of blur together, so whatever. This is a good slide, actually. Like, look this up. OpenTextBC.ca. That's a good. This is a good list of things that we go over in the other video. So, like, all in one place. Degree of relationship. I talked about that. That's how many. That's not in here though. I've saw. Anyway, let's get back on track. I apologize for these tangents, but I think, in my opinion, they're valuable because I'm adding stuff. You can read all this, right? What you got for me is to point out things that I think are important to like remember. So the business rules. What are the business rules? Well, I'll let you figure it out. Just one example though would be one piece of hardware can have many pieces of software, many instances of software. It can have lots of different software installed on it. That's just one business rule. And you know that from looking at that relationship diagram. Okay, so that we can learn how to populate a database from an external source, let's import records from an Excel spreadsheet into this database. To me, this is once you get a job and you're doing database stuff, you learn how to do it for that system thing, but it's probably good that you see how to do it too as a student. This is going to vary from scenario to scenario, but all right, I was kind of rambling there and I had some issues, so we're going to edit that out. So what you need to do for this one, I think this varies a little bit from the directions. What you want to do is go to your access objects. So notice like you still have the employees, you've got software, but you don't have anything for hardware and config. This is the stuff you're going to populate. So it says something about going to external data here in Excel. Don't do that. Right click. I know this works. There's probably a way to do it up here that I'm missing somewhere, but I know this works. So if you right click on the TBL hardware table, go down to import, go to Excel, you'll get these options, and this is for it's back on track with what the instructions say. Again, if there's the way it's telling you in the instructions is correct, I'm not sure where it is. But anyway, you want to browse, make sure you get this wherever your TBL hardware Excel sheet is. So this is the Excel sheet. You browse for it, and then make sure you click on this. A new table would create a whole new table. You already got the table. You just want to add to that table. Right now it's empty, so you're adding stuff to an empty table, which fills up the table, has that effect, right? Make sure you pick in the drop-down menu here, make sure it's TBL hardware. You don't want to put the hardware data into the config table. Probably won't let you anyway, but better safe than sorry. So TBL hardware and the Excel sheet location and append. Click OK. Currently open, yeah. If you've got yours open like I do, make sure it'll close it for you if you click yes. And then it'll show you the data. I think you could just keep clicking next here. Let's see if this works correctly. Make sure it says TBL hardware there. Don't do the analysis. Forget that part. Don't check that box. Don't save the import steps for now. And then double click on the hardware table to see if it did indeed fill up the hardware table with data. And it looks like it did. So here's the thing you got to realize about this. You have to do the hardware table before you do the config table. And the reason why is because of referential integrity. If you had tried to do the config table first, referential integrity would be violated because you would be trying to put data into the config table that didn't exist yet in the hardware. You would be trying to put the foreign keys for the hardware into the config table when you don't have the primary keys to refer to in the hardware table yet. So you have to do the one side of all the, if you go back to the relationship diagram, which I don't want to open again because then I have to save it or whatever. But if you go back and look at it, you have one in infinity. All the ones have to be done before any of the infinities. So notice hardware is got an employee. It's on the infinity side and the employee's on the one side. What you notice is the employees is filled out. So what that means is that I think it's assigned. There's like employees that I think this is like you loan out like this instructor needs a computer. We're going to assign this computer to that instructor. That's what the ass means here. Assigned to means this is a foreign key. The value here is the primary key in the employee table of that employee. So employee number 1 is assigned hardware device number 1. Hardware ID number 1. So if you didn't have an employee number 1 in the employee table, you could not put this record in because this has to have something to refer to already. If any of these employees had not existed, like if there was no 11 over the employee table, no 12, then you could not have inserted that record. So you would get these probably errors if you tried to add the hardware and those employees didn't exist. If you want to like go around, like save another copy of this and try this out, I don't want to show it in the video, but like delete some of the employees and then try to add the table, do the import of the hardware table, you'll see what I mean. So you got to do the one side first, and then you can do the many side. So it's almost like parentheses in math. You got to work inside, outside, in. It's one way of looking at it. Lots of different metaphors, I guess. So the next thing I think we do is the config, because that's all we have left. Let's look and see. After you do the hardware, ask you a question. I think it says how many. If it's successful, you should have 21. So we have 21. Keep in mind, this is the hardware ID, this is the primary key, and it starts at 1 and counts up, and that's probably the way Access does it. It just adds 1 each time you add. That ensures it's unique, right? If you add 1 to the thing, the latest, if you add 1 to the highest number in the primary key column, it's a new unique number, right? You don't get to 100 and then go 101 and 101 again if you're counting up. You don't count the same number twice. You always add 1. So it's always unique. That's a very, if you remember my video, I talked about surrogate keys. HID here, EID, SID, these are all surrogate keys. They don't come naturally from the data themselves. They're not like the serial number of the hardware or something. That would be a natural kind of data. That could also be a primary key if it's unique. But it would be a natural piece of data that you're using for the primary key. Or you could combine all the values of the row together and make a primary key out of that, as long as it's unique. That combination is unique. But often the most efficient way to do this is to create a key kind of out of your butt. You make up a key method for making it unique, and it's called a surrogate key. This has nothing. One has nothing to do with that particular hardware device. It's except that you use 1 to refer to it in this database uniquely. That's a surrogate key. Okay, back on track 21. So what I was trying to, this is like a big tangent off the fact that it says 21 here, you see 21 here. Just because it's the highest primary key doesn't necessarily mean that's the number of records. You should really count them to make sure, because some of them could have been skipped. Maybe something was deleted, and you only have 20, but the one that was deleted isn't repeated usually in this kind of scheme. It's like retiring a jersey number. You never use that number again, so you might actually only have 20 because number 19 was deleted. So double check that kind of stuff. 39 for the config. So do the same thing with the config table. So let's see if we can do that. So right click on config. Let's close all this stuff actually. There, I saw close all somewhere earlier. There it is. If you right click one of the tabs, close all. Do say yes, because we just imported some data. So you want to make sure you save that import. Go to the config table. This is the bridge table, the junction table, the associative entity, whatever you want to call it. There's another word I always use a lot. It's not routing table. What is it? Junction table, bridge table. Anyway, right click on that. Go to import, Excel. Browse to that directory again. In this case, pick the config Excel sheet, append, make sure it's going to the config table in the drop down menu. Click OK. Just keep clicking next. Don't check the box. Click finish. Don't save it. Don't save the steps, the wizard steps. And then double click on config and see if you've got data, and we do. So what this is, again, it looks like the primary key of software is just the S followed by a number. I don't know who came up with that, but as long as these are unique, that's fine. But they don't have to be unique in this table. That's the key thing. The only thing that has to be unique in this table is the fact that when you combine this thing with this thing, you get a unique value. So you should only have one. You should only have one 1s3 in this table. You should only have one 5s3 in this table. You should only have one 14s6. You can have lots of 14s, as you can see here. You can have lots of s6s, as you can see here. But you should only have one combination of 14 and s6. And what that means is that software program application number identified by S6 is installed on machine 14. That's what that means. I hope that's clear. That's how adjunction tables used. So the combination of the two is the primary key. I think when I looked at design view, I didn't. Oh, now see how there's a key in both. The combination of this value in this column and the value in this column should be unique, and that composes something that composes a primary key. Those two fields combined together defines a primary key for this table. And in turn, both of these, the two of these things that comprise the composite primary key, again, one of them is not the primary key. HID is not the primary key. SID is not the primary key. HID plus SID is the primary key. But both of those things individually are also foreign keys from the software and hardware tables. Notice this HID and SID, you could have called them something else differently. You could give it a different name in this config table if you wanted to. You could have called it hardware ID and spelled it out, for instance, and then said, you could call it hardware and software, actually. And then they would still be foreign keys, and together they would be a primary key. It refer back to the primary keys of the two tables. So the naming is not the important thing. The fact that you define them as foreign keys is the important thing. I'm trying to remember how you do that. Access. There's got to be a way here somewhere. But look up. That's not what I want. Oh, I'll figure it out later. You don't have to know it right now, so it's not important. Okay, so next step. So we got the, make sure it's 39 records. So it looks like it probably was, I think. Oh, yeah, we'd have to count to see. There's a quicker way to do this than just counting. Oh, it says it down here, 1 of 39. Yeah, I forgot. Access shows it at the bottom. Tells you how many records you have. So we've got 1 of 39 selected. If we click on one of these other ones, it'll say 28 of 39. So this is the 28th record. All right. Next step. This is going to be another long one, but we're going to do. So I'll let you answer the questions. Like for here, you need to paste things or whatever. So updating data. I might do all this at once and not painfully show you each step. I'll let you figure it out, and then I'll show you the end result, and we'll go on to the next step. So let me pause and read this. Okay, I've read this, and I'll show you at least one of these, and I'll let you do the other two. So I'll probably do A and show you, and then you can figure out how to do B and C. But notice this thing. We'll fix these. Let's add some personal data. So, okay. It says, I do want to point this out because what was it say? In our newly imported hardware assets table, notice that some of the processor speeds, hard disk capacities, and memory capacities seem suspect. This is most likely due to laziness on the part of the technician who's not updated all fields in the spreadsheet when upgrades have been made. We will fix these in a subsequent lab. I don't remember that ever happening. I've done all these labs. I don't remember that happening. I think the intent of that, which might have got neglected, is that if you look at the hardware, it was the thing that I was saying. This is the thing that I noticed right off, and that was before I saw that I did when I first opened this. I did not like these GBs and MBs in here. So, and the gigahertz. These are all gigahertz, so they're probably okay. If there's something else that's meant by that, I don't see what it is. If you just had processor speed in gigahertz, then 2.6, that's what it should just have those numbers in there. And likewise with the memory capacities, but it will come. Don't worry about it. You don't even have to answer it right here. Well, all you need to do is add yourself as an employee. So let's see how to do that. The thing about Access, I haven't done it in a while, but I think I can remember how to do it. When in doubt, just double click on something and you'll notice it has, this is called, again, I think this is the data sheet view. Be careful what I say there. And you'll notice at the bottom, see where the asterisk is? you should be able to type in here. So what I want you to do is skip the employee ID. Don't put anything there, and just go to the last name. Put your last name, and then put your first name. And you just click enter for both of those. And so index primary key it cannot be null. It doesn't do it by itself. You have to manually do it, don't you? That's kind of lame. I was hoping it was auto increment, and I'm trying to remember how that does it. But notice, I put 22 in there. Let's see if I go back and put 21. Watch what happens. This is that's the first time we really demonstrated what it means for it to be a primary key. And the DBMS, if it's designed correctly, should prevent you from doing what I'm trying to do, which is put in two 21s there, 021s. You can't have two values that are the same in that column. So the changes you requested in the table were not successful because they would create duplicate values in the index, primary key, or relationship. So it says an index also has to be unique because indices need to be unique to make searching faster. That's a purely functional thing. It's not necessary. It's a database thing. I would say it's not necessarily a relational database thing, strictly speaking. It's just something that makes relational databases perform faster, maybe. The primary key itself, too, is indexed. So if you look, it's better. Let's fix this first, then we'll talk about it. 022. You could put anything that's not one of these in here, and it should work. And if you then go to, just hit enter all the way until it's done, and then go and right-click on employee and look at the design view. If you notice, if you've got the primary key selected, and you go down to the field properties down here, you'll see that it says yes, it's indexed. So primary keys in most database management systems are automatically indexed. That's just something that happens. But you can have fields that are not primary keys that are also indexed. And then what that means is that if you search on that field, it's a much quicker process than it would be if it were not indexed. Okay, so if you are at this point, this is what you would do. I don't know if you guys know this trick. Most of you probably do. Maybe I'm the last person who learned it, but I didn't know about this. I used the snipping tool for a lot of screenshots, but there's something better. I accidentally did it one time. I'm like, how did I do that? I eventually got it memorized. It's really simple. You do Windows, Shift, and S all together, those three keys, and that will give you this sort of screen capture. Everything will be dim, and then you have a crosshairs, and you just pick the stuff that you want to. This right here for this one, this would be good enough. So you draw a box around what you want a screenshot of, and then let go. So drag your mouse, take that screenshot, and now it's on your clipboard. And then for this assignment, what you want to do is go stick this, get rid of the B, get rid of the 9, and stick that in there like that. That would be acceptable. And so on for the rest. I'm not going to do all those steps. So I'll let you do it. So that's part A. Let's go to part B. So I think this is where we do some queries. I didn't check this link. Let's see, control. I don't remember checking this. Watch it not work. I think it's a support. It's a Microsoft. These should always work. These Microsoft ones. So yeah, that shows you. So a query is like how you kind of ask a question to a database to get some information back, right? You asked for some result of data that gives you some information. So we're going to use the query wizard and query design view to set up single query follow. Yeah, so let's just do this, and I'll show you how it works. This is not. It's better once you learn SQL, in my opinion, to make these queries. But not everybody who runs a database for the dentist, like my example, a very small business, right? It's going to know how to write SQL, but they might be able to do this wizard visual way of asking queries. To me, it's harder. As a matter of fact, I don't always remember how to do it in between the two times, from one time to the next where I'm doing stuff with access. So let's see if I can figure it out. I'll show you how to do it. All right. Let me just, I was going to pause, but let's just read what it says. So for a list of all hardware assets, displaying only the category, manufacturer, model, serial number, hard drive capacity, and memory capacity in that order. Save the query using the name hardware list. Close the query. So this is the first thing you want to do. and you want to create the query and then take screenshots of these things and paste them in. But let's look at it first. So what I want to say about this, if you listen to the video lecture, this is what's known, this part right here where you say you display only this column, this column, this column. There's a bunch of columns, but if you're displaying only those columns, that's the term that's called projection for relational algebra operations or whatever. That part of the lecture where they're talking about that, the term for just showing certain columns is called projection. So this is, we want a projection of the category manufacturer. I don't even think of that word when I do this. I just say I want these columns, right? And then I write the query or whatever. But I'm saying that because that's like a term you'll have on a test or whatever. You need to know what a projection is. So it's a subset of the columns. So this list is asking for a projection. The projection will be across all the rows because it doesn't say anything about it. Wants the whole list, right? But it just wants these columns for the whole list of all the software. All right. So from this view, you want to go pick create from your menu, your top menu here. So you got file, which that's that's distracting. Home, create. So under create, you want to look in the toolbar and look either one of these two, query wizard or query design. I want to use query design, I think, because the wizard sometimes takes me down a path I don't want to go, but maybe I'm remembering that wrong, but I think I trust this one more. So let's click on query design. And what you want to do is, I have to remember how to do this. I'll tell you what I need to do. What I need to do is pick the tables that are involved in the query. I think there's only one involved. It's we want a list of certain columns from the hardware table. So it's only the hardware table. Let me see if I remember how to do this. Okay, I did a little test to make sure I remembered right. So what you do is direct manipulation in human-computer interaction terms. You click on the table you want and drag it onto this field here and then drop it. And that will add that table to the query. Now later on, when we do joins, you can do more of these tables together. But for now, this is the only table we want. And then we want to do a projection of only those certain columns. And the way you do that is you go down to the bottom here. You do a lot of work in this part. Once you got the table set up, you'll go down here and do a lot of work. And what we want to do is list off the field. Remember, the order matters. So a list of all hardware assets. That means we don't, the selection we do is the term in relational algebra is called selection for the subset of rows that we want, the records that we want. In this case, we select all of them. So the selection is all. So a list of all hardware assets displaying only the categories first. The manufacturer, so go to this next thing over here and find manufacturer. Model, serial number, hard drive capacity. Now we'll learn about some of these other columns here later, but for now, just like look at the top button and make sure you're clicking the right thing, unlike what I'm doing. Hard drive, okay. Hard drive capacity and memory capacity. If you leave one of these out when I'm grading, that's RAM. I'm not going to fret about it too much. The intent is I can see how I can, because there's a long list there, so it's possible you might miss one, but try not to. So even double check like I'm about to do. So again, the list is category, manufacturer, model, serial number, hard drive capacity. It's just called hard drive in the column name, but what that column name means is the hard drive capacity. And RAM, memory capacity. That's the size of your main memory is what they're calling RAM. I don't like that term. It should just say main memory capacity in my opinion, but whatever. So those are part of the query now. See how you got the check boxes? That means, here's the thing, you can create projections that involve certain columns in the query, but you don't show them in the projection. That's why you have these check boxes. In this case, we want the check box in all of them because we're going to show all of them. And then once you think you've got it, there's a few different things you can do here, but like run's probably the most useful. So just click run, and this should show you the results. Notice this is something I talked about in the lecture. The result is a table. You might call it a virtual table. It's not a table object that's stored in the database, but the display you have here, notice what it is. It's a bunch of records, a bunch of rows, and a bunch of columns. So some amount of attributes from some amount of tables and some amount of rows from some amount of tables. But what I'm trying to say is the input into this was a table, so columns and rows, and the output is columns and rows. This is the closure property of relations. You're creating sort of a new relation, maybe not technically speaking, because there's no primary. I mean, there is a primary key here, I guess, in the sense that if you combine all these values of the row, you probably get something unique. But don't fret so much about whether it satisfies the criteria for being a table in a relational database. Just notice that the structure of the output is the same as what you put in. So you get a series of rows and columns as a result from your query. So if you look at the hardware table, let's do this first. I guess you guys can count, but actually before we do this, let's save it. So save the query using the name hardware list. So right click, save, and there's a different place you can do this too, but I'm going to just do it here. Actually, I think if you try to close it, it'll ask you if you want to save too. That's another way of saving it. But so you type hardware list here in the query name. So we've got now you notice it's a new object stored over here. This is something that Access does. I'm going to close this so I can always get it back. All right, just double click. If I double click on hardware, you see I've got a lot more columns, but I should still have 21 results, and I think it's the same here, right? 1 of 21, because the selection was every row. The projection was a subset of columns. So this is a projection, the fact that you have only this many columns, not the maximum amount of columns that are in the whole hardware table, is the projection part. All right. So what you would do, I think you know how to paste already, so I'll let you figure that out. And I'm going to let you do, how many more steps are there? There's not a whole lot more steps, and we're already an hour in anyway. So I'm going to go, because the queries are a little harder conceptually speaking. So I'm actually going to help guide you on another one too. So we're going to modify the previous query by opening it in Design View. So you would go down to your query. Open it in Design View. Remove the hard drive, RAM, and serial number columns, and a three-way sort alphabetically by category in ascending order. Finally by model. Is this English? Hold on. Modify it. So the way you would modify it is you would go down here to the bottom, and what does it say to do? Remove the hard drive, RAM, and serial number columns. Let me see if I remember how to remove them. So what were they? Yeah, remove the hard drive. I think the way you remove it is you just, let me see. I have to remember. All right, this is at least one way. You can make it to where they don't show, but that's not the same thing as removing them from the query. I don't want to save. So this, if you go to the one that you saved, this is the same one we just did. Go to Design View. Click on the column you want to delete from the query, and then go up to here where it says delete columns, and just click delete. There's probably, I think you can hit the delete key too, and some other things. So we're modifying to get rid of the hard drive, RAM, and serial number column. So hard drive, RAM, and serial number, they're all right next to each other. So, and you can probably multi-select somehow. I'm not going to risk it. I'm just going to do them one at a time. So these are only three. Now what we need to do is, so let's just run the query, actually, make sure it still runs. So you get these three things, but what we want to do is put it in order. What was the ascending order, alphabetically by category, and also by manufacturer in ascending order. And finally, so what this is saying is you're going to show these three columns. First sort by category, then by manufacturer, then by model. So the order that they're in here, yeah. So in other words, if there's two things that are the same category, then you go to the manufacturer to sort them. And then if you got those two things that are the same, then you finally go to the model as the last thing. And it looks like we got some repetitions. We got duplicates here because, of course, there's two HP desktops that are HP pavilions. So this is not unique stuff. But again, this is not a table. This is the result of a query, which might give you some duplicates depending on which columns you pick. So, for example, if you have 100 employees and 3 of them are John Smith, and you print out the first and last name of every employee, you'll have 3 John Smiths. So same kind of thing going on here. So the way you do the order by, basically, is what you would call it in SQL. And underneath all this, you can see there's I'll show you, maybe it's the last thing. You can look at the SQL view of this somehow if I remember how to do it. But the order by is sort. Yeah, so what you would do is you would pick ascending for the category, then you pick ascending for the manufacturer, and then ascending for the model. And then double check. I think that's the right way to do it. Ascending means you start low and go high. So in the case of like words, it'll be alphabetical or alphanumeric, actually. If you have any numerals in there, it'll do. There's something called alphanumerical sorting. But let's run it. Basically, it'll be in order by ASCII value is how it works. But so you notice the desktop comes before laptop. Dell comes before Gateway, comes before HP. Comes before Dell when it's a laptop, and then then IBM when it's a laptop. So you see these are, so sort by this first, and then sort by this if they're the same. So there's a bunch of desktops, so then you go over here and sort by the second thing. So then when you get in the laptop area, you'll have Dell before IBM, obviously, and then when there are 2 Dells, you got Dell Inspiron. Dell Inspiron's before Latitude, I before L, right? So that's how that works. That is the stuff that you want to paste for that second query. Let's look at the rest of this. So increase the width of the columns. And you can look at all this on your own, and I'll let you. So repeat the process of verifying and inserting screen captures for each query in the steps below. So you have some more queries. I think I'm going to let you do this part. There are videos for you to watch. I didn't verify all these links. Let's see if this link works. Okay, so these videos seem to work. I'm going to let you finish this. I'm just going to point you in the right direction as a final send off. Criteria is this thing right here, and there's certain things you can put in here to help you do selections, basically, is what this comes down to. We've had projections, so it's just a subset of columns. Selections are a subset of records. So in these queries, you won't have every single row anymore. You might only have a few rows. And that's affected by doing criteria. Each criterion, right? That's the singular. Criteria is the plural. The word criteria is the plural. Criteria are the criterion is. Anyway, the criteria are different things like greater than, less than, equal to, stuff like that. So I'll let you watch those videos and give you a break from me. They'll probably be more to the point as well. That's a benefit. The benefit of me going over this, in my opinion, is that I pointed out, one thing is I showed you, let me go over here. I showed you some of the mechanics of how you would actually do this document, right? You put answers in here, type in, and it might help if you do like a different color font. That's nice always, like a red or something. How you pasted it in. If you've forgotten already, it's Windows Shift S if you don't know that trick, and that lets you just all the time, whatever you're doing. It's really nice to do a quick screenshot, or portion of a screen, right? Snippet, I guess. So, but the main thing is that I talked about some of the concepts that were in the video lecture and the reading too, or the slides, however you do get your concept material, learn the concepts, however you do that. I'm trying to relate this exercise to those things. And again, I don't know why I said again, but Access is sort of some people would call it a dumbed down version of a real database. I think that's sort of unfair. I do enjoy other databases like Oracle and SQL Server and MySQL more. I enjoy actually writing SQL queries I did say I would show you. Hold on. If you got a query, right click. I'm going to pause. When in doubt, right click. I right clicked every wrong thing before I right clicked on the tab up here. But if you right click, and there's probably like a key, hotkey for it too. You see where it says SQL view? This will show you what the SQL for the query would look like. It's a little verbose because you have like the full path to the table and then the column for each one of these. This one's not so bad, and I can't seem to see how to zoom this. There's a way to do it in Screencast-O-Matic, and I forget it every time. But what it says is select category, comma, manufacturer, comma, model from table hardware, order by table hardware category, well, by category, comma, manufacturer, comma, model. This is how you would write the SQL query. You can see it's fairly simple, right? I think this is easier than the right brain picture way of doing it, which is the design view. I would rather write the SQL query, especially for a really complex query. It's a lot easier than, I'm not even sure how to go about doing certain tasks in Access instead of doing SQL, but whatever. I did say I'd show that. So the main thing is, the main thing I feel like this gives going over this is just to get you on the right foot started. It's not meant to be like a whole tutorial for the whole thing. That was kind of 80% one, right? But I want to remind you of the terms, the theory that this is the implementation of. So in further Access Lab 3, we'll go into a little bit more detail about some of the stuff I've already covered in lecture. If you have any questions about this, let me know, and this should be up before I go to bed tonight. So if you see any errors or whatever, don't feel free to let me know. This is not a perfect production, so sometimes things get missed. But talk to you guys soon.